Hey, this is David G for Brocade. This is a Brocade Workflow Composer and NAPALM demo. This is a short video on the network automation and programmability abstraction layer integration for the Brocade Workflow Composer, or in other words, the NAPALM pack for the BWC. So what is NAPALM? NAPALM gives us a set of Python classes that has a number of methods, and these methods are mostly getters, so it might be get ARP table or get BGP neighbors or something like that. There is a whole list of these getters. It also gives the ability to send CLI commands to each of the devices and also do configuration merges and replacements. NAPALM is really cool. It gives us a similar set of function calls for different kinds of devices. So it could be Cisco iOS or XR, XE, EOS, Junos, and there's a whole list of supported devices on the NAPALM website. So let's look at our topology. I have three routers, a Junos router, an iOS XE, and an EOS router. There is a peering LAN. We've got full BGP peering or full mesh in place on the peering LAN. Each device is advertising a prefix. So we have router 1, the Junos router, is 10.10.10/24. The iOS XE router is actually Cisco CSR, is 20.20.20/24. And router 3, which is the Arista EOS, which is 30.30.30/24. On the management LAN, we have the latest version of the Brocade Workflow Composer, so 2.4 with a NAPALM pack. The pack is configured and connectivity is in place for both of the LANs now. BGP is already up. The prefixes are being advertised and received by their respective peers. And we've got a number of exercises. So the first one is get ARP table. So let's go across here. So what we're going to do now is get ARP table action, and look at that. Token expired. Just to prove this is a live demo. Is it going to let me in? Nope. Oh, yep. There we go. We have the get ARP table action under the NAPALM pack. Host name. Now, because I have configured the NAPALM pack, let me show you this. I don't have to put in the IP address. I don't have to put in the driver or the credentials or any other input for that matter. So what I can show you is what the config file looks like. So we have the config file. The HTML class allows us to do prettified emails for things like some kind of failure or config change. Config repo is actually for a golden config workflow that's in the pack and is not relevant for this. Credentials, CSR, vSRX, and EOS, all the credentials required to log into each of the devices. Obviously, I'm not giving anything away here, me being very creative and all. And the devices, so hostname R1, port 22, driver Junos, and credentials vSRX. So this credentials section here links together this set of credentials for the device. The driver is a Junos. I'm not making this up. This comes from the NAPALM documentation. And port 22, so this will connect onto the SSH port and use the netconf subchannel for that particular driver. For hostname R2, this is iOS. This is the Cisco CSR. Port 22 on SSH. Now we know this is the CLI driver. This doesn't do netconf, it's not doing REST, anything structured. For R3, we have port 443. The driver is EOS, so this is using the REST API, or the, I think is API. All the information's in the configuration. It's loaded into the BWC. I don't have to reference this, and we can prove this out. So if we go to R1, and if we just go back to our diagram, R1 is the Junos router. What we should be able to do here is run the action, and I'll keep the executions tab open, and we should see shortly the ARP table come back, and here it is. Awesome. So we have the ARP information from the Junos router. For the sake of brevity, I'm not going to go through every single router. Let's just go through the list of our demo actions. So get BGP neighbors. Let's do this one on a different one. So let's go R2, which is the Cisco CSR, for instance. And let's run this. Again, keeping an eye on the executions output. Let's see what happens here. Might take a few seconds. Here we go. So this is the BGP neighbor information from the CSR. These are the peers, uptime, address family, prefixes, etc., etc. So far, so good. Let's get a route. So this will be for get route 2. Let's do this on R3. This is the Arista EOS destination 10.10.10.1. Now 10.10.10.1 is via the Junos router. So let's run this and let's see what information comes back. Now the EOS API is pretty quick. This is via the 10.10.10 route, which is excellent. The next top is 192.0.2.1. Now, interestingly, it's also receiving the prefix from the Cisco router, but the AS path here is different. So each of the routers has its own AS. Router 1 has 655.0.1, router 2 has 655.0.3, and unimaginatively, router 3 has 655.0.3. So we know this is our best route. And then the last thing we can do is we can add configuration. And what we're going to use for that is we're going to use the load configuration. So what we have is, let's add some information. And the information that we have to add comes from a set of configuration files. Now I have a directory on my VM, and in this directory are some configurations. I have a Cisco IOS configuration, and I'm going to add a prefix list, and this could be modifying a prefix list. Again, this is a merge operation. Here is the EOS prefix list, and here is the Junos prefix list. All of these three items can be merged. Now I've already got sessions open, so show policy options. There is no Google prefix list here, and I've got a timeout on there. Let me just log back into here. Prefix lists empty. Empty. So that is the EOS, Cisco CSR, and Junos does not have the Google prefix. So what I'm going to do here, I'm going to show you the power of this. This is pretty cool. So hostname R1. Don't have to put the driver credentials in. The config file is it is home dg wasteland. R1 is Junos, so I'll do Junos prefix list.config, and let's just validate the name of that file again. It is indeed Junos prefix list config. Method is fine. Now, inline transfer, this is an option for primarily Cisco IOS. So each driver merges the configs in different ways. Cisco IOS tries to do it via SCP, and that relies on the enable password being set. So what I've done here, I've added in the inline transfers to true, which basically says don't do it via SCP, go do it via the SSH channel. Now, because this isn't a Cisco router, inline transfer doesn't matter here, and I know the driver doesn't do inline transferring. So I'm going to set that to true, and what I'm going to do is I'm going to run this, and whilst this one's running, I'm going to whiz through, go to R2, and I'm going to now do the CSR prefix list and run that, and I'm also going to go to R3, and I'm going to do the EOS prefix list and run that. And hopefully, load merge successful on R1, so that's the Junos route that's taken. Load merge successful on R3, so that is the EOS router that's taken. And we are waiting for the Cisco one. It does get there in the end. In a moment. Come on, Cisco, you can do this. There we go. So we have all the configurations been merged. So now if I do show policy options, we can see the Google prefix list is there. If we go to the Cisco router, we can see the Google prefix list is there. And the Google prefix list is on the Arista API as well. Sorry, via the Arista API, but on the Arista router. So, audience, ladies and gentlemen, boys and girls, this is it from our short demo. we've gone through a get ARP table action, a get BGP neighbors action, a get root action, and added configuration to each of the routers. Now this could be much more complex. It could be adding in, say, EVPN configuration, and we could possibly do that via some kind of a template. But that is it. So thank you, and tune in soon.